that I'm asking to pick up from you. The number 8, that was on your own paper that we took some notes on last class. And then the number 6, which was integration by parts, that you finished up last class. So make sure your name is on each of those. Come give it to me in the basket. And then I'll tell you what today's plan is.
My six has my name on it. Yes, it does.
You don't. It's actually you don't want to. It's easier to hold it farther back. As teacher.
Would you be willing to fill this out for me for me?
Yes, sure. Give me a few minutes to get it filled out. Okay, let's go ahead and talk about the plan for today. Braden, will you shut the door, please? Thank you. Everybody's here. Okay, so today, if you've taken a look at the 2 handouts I gave to you, both of these should be considerably easier because these are not BC topics. These are straight up AB topics. In fact, the first one, the antiderivative stuff, you've been doing some of this already the first couple weeks. I'm just asking you to do a little bit more for some practice, some basic questions, not even integration by parts, not even partial fractions. I think there's a couple U substitution questions on here. But again, the benefit of BC and what makes BC easier is sometimes we can take a step back and slow down a little bit and still get in all the BC content. So I would like you to do both of these today, number 9 and number 10. Obviously, if there's something in those that you're struggling with or you don't remember, you need to re-remember them. The fact that I'm giving you class time to work on these and review these means I am likely to pick a couple of these question types for our first quiz when we get there. Additionally, the reason why I want to do just an AB day, well, not just because it's a Friday, but on our class website, I will put an extra practice worksheet on integration by parts. So this number 6 that you turned in to me today, the integration by parts, it seemed like when I checked with y'all last class, you were feeling pretty good about it. It didn't seem like you guys were in need of a lot more practice, but that may not be true for everybody. So, again, by not moving forward with the next BC topic today, that gives you some extra time to get integration by parts down if you need it. So, do assignment 9 first, please, then assignment 10. Work together, check your answers. Answers are online. Let me know if there's something you disagree with. Let me help iron that out. And then at the end, when you've got both those done and you've checked the answers to both of those, if you think you need more integration by parts practice, just on a separate sheet of paper, you can go to the optional worksheet that I'll put on our class website. So that way everybody should be kind of up to speed by Monday. Yes?
Is our quiz or test gonna have a curve?
Depends on the difficulty of the questions.
Okay.
So, for example, like our integration by parts worksheet that you just turned in. Most of these questions are just do integration by parts. So those, unless it was like a more complicated version, I wouldn't see the need to curve those questions. If they're questions like the ones you've been doing on the back page that are released AP questions, then I would, if I do a bunch of AP questions, then I would give some curve.
Cool.
So it just depends. The harder it is, the more of a curve there will be. But hard based on class to average, not on hard on how you feel about it.
Gotcha.
Okay, so Will's out. Everybody else is
Are you doing others? Checking.
Mr. Townsend. Yeah. Would you be willing to do Maddox and mine as well?
Sure, I'll do yours.
No.
You offered.
He offered for me?
No, I offered to take it over to you.
Apparently. It's a good one. I like it. But you need something new. I like that one. And I don't feel like, huh? I like this one a lot.
Okay, bad news for yours. So I don't think these two from the new school,
Number 5.
since those don't have grades, they're just pass
There you
fails.
go.
I don't think those factor into your GPA. But this was AV, pre-calculus, algebra 2, geometry, and I didn't see any algebra 1 credit.
Yeah, so we're working on that.
Okay, I can't let you know that.
Yeah, yeah, well, thank you, yeah.
So get the square out of the denominator.
No, I did, it's just not on my
Basically just
calendar.
move the denominator.
And also the new schools, like, register is like changing,
Yeah.
so.
You get x,
Yeah.
1/2 x to the
We're working on it.
minus 3 x to the
graduating, so.
and then it's just
That would be really funny.
You had, okay, so yours, I can actually look at your real transcripts, we get the version of that, so I can't see any of your other stuff. I saw, AD and pre-cal, those are the only two that I saw. So that's probably not, I'm assuming your transcripts on the rule.
cosine over sine, yeah, will be secant squared. So secant squared is
Are you integrating it or are you?
integrated. 13 is including functions. It will just be, because that equals secant squared. And the equal secant squared is 2.
I know, I could do it. That's it. Excuse me. Bless you. Thank you, John.
Pretty simple stuff. I have to do this physics reading tonight.
You don't need physics readings right now. Like 50.
Good tool.
You're gonna say so. I thought you were gonna say.
Oh, what's 5
Are you on number 5?
Yeah.
Yeah.
X.
No, I'm on 14.
You're such a nerd, bro.
What?
Is tangent squared x plus 1 secant squared x?
Yeah.
And then integrating that is just tangent. So yeah.
Yeah, that's what I did.
What turns the secant in? What's the integral of secant? Just secant?
So what's the answer to the 5?
Thank you.
2 over 3, x to the 3 over 2, minus 6, x to the 1 over 2 plus c.
Student's name. Tommy?
How's it going?
It was
Good so far?
No. That's
harder
than others
yet?
Oh, I have to.
Number 5 is harder?
Yeah. You have this.
I'm doing
Oh, yeah, that's how you say it, okay.
I'm doing the
How's
science.
it?
got
Like what?
I always say moo.
I don't really understand it.
Blue alpha.
Right,
I'm
trying to
doing the
explain it
science.
to you?
We're gonna have some work there on that one.
That's
Is
true.
this
I
a
will.
typo? Should this be?
Erase that.
parentheses?
You had to show your parentheses.
Is,
Obviously, some of these are, you're gonna need to show your work too.
I forget
Some
what
of them you
it's
can do in your head, I think, but.
is it called Science Honor Society called?
So like, isn't
SMHS.
What?
I thought there was like a weird like
No, that's only me walking through
I
now.
was thinking there was like a weird sorority type name to it, like
You mean Greek letters?
Yeah.
Well, the reason why it's called mu alpha theta is because it's M-A-T-H pretty much. Oh, he's just.
Wait,
Of course you would know that, Brendan.
Whoa,
Wait, where's the H come from?
Wait, where's the A?
Theta.
TH.
Oh.
Anyway,
I thought that was just common sense.
Go out for data honors.
Whoever made that's really cool.
When it's
On
when it's
this
fine
one?
with the x.
Wait,
you
I'm
can
gonna start a
fraction.
fraternity exercise.
This
Go on,
over the
join.
denominator, and then
Yeah,
minus
it's
that.
gonna be, sigma alpha
Put those
to-
two fractions up, you can work the two separately, it'll be easier.
Thank you.
How do I join?
5 to
Don't down
the
that
x.
Or sigma
harder than the
sigma.
rest.
Integral of 5 to the x is.
Okay, so what?
Yeah,
Well, what's
like,
one?
like half just gonna be an easy
Okay.
one.
I guess it does. It's
fine. But I just told him about number 5, that
Is it
sounds like
5?
that might
It's
be.
not 5 to 2x.
If you split these fraction up,
I'm
do
number
x over the
14.
denominator,
Why don't you show
and then
some
minus
more?
3 over the denominator, then you should do those two parts separately. And that
You
might
don't
help
have
the
to
one
show
or
it.
two
That's
others also.
kind of what I was thinking of doing, and then
Maybe
I
if
just
you
kind
wrote
of like,
your
was
thoughts
like, okay,
down.
that's a lot of work, I'm just gonna get the rest
Have
of
you
it
done
done.
Have you done number
Let's move
11?
on.
Have you done number 11 yet?
Yeah.
Is it
How
just
did you do
That's
it?
exactly
Uh,
what I'm
I
just
just
like, okay,
Isn't
I'm
it-
done.
Is it
done
easy? So-
isn't it just like sin x
Negative
plus
5
5 over
cosine
natural
x.
log 5?
Oh. Is it natural log?
You wanna go?
Natural log of 5.
Yeah.
What's wrong with this
Plus
one?
c.
Might just skip that one.
Wait, so you just leave the 5?
Yeah, that's what it is. Natural log of 5.
Not because you need.
Why do you leave the 5?
Okay.
Because it's a constant.
Oh no, I don't know what the integral of 5 is.
Whoa.
No, I'm on number 7. I'm just kidding. Oh, is it?
Oh my gosh, how did you miss number 7?
I didn't miss it.
Yeah, you did.
How?
Wait, no way.
Oh my, wait, no I didn't.
Yeah, you did.
No I didn't.
Yeah, you
Oh,
did.
yeah I did.
Plus c.
Are you remembering your plus c?
I didn't.
Yeah, I've written plus c for every single one.
Proud of you.
Not doing okay? Sure. Probably. No, that's fine.
Too much work? Uh-huh.
Well, that's number 5.
Let's see 11. Did you get negative 5 cosine of x minus 3 e to the x plus c?
Let me see your number 6.
Okay,
No.
Why?
I'm secant. Just secant.
What I would
I
recommend
got
is
memorize
just split apart this fraction. Try putting x over this,
I'm gonna memorize this.
denominator, and then
Uh,
minus 3 over the denominator, and then you can integrate the two separately.
This guy just said.
I don't know, if I bring the power down, it would cancel those, lower the power by 1, which would leave you x to the 1
Oh my
half
god, I just skipped a whole bunch
minus. If I bring the power down, that would be a 3. Lower the power by 1, which would be x to the negative 1 half. And then you need a plus b, but I don't know why. Wait, well, you've got this circle.
nothing.
Oh, wait, I'm sorry, yeah, I was checking.
Yes,
Yeah, that's fine.
Trigger roll.
Yeah, basically.
Also, you don't have to do it right now, but all the answers are on the website, so you need to check out some points.
Okay.
I had to think about it for a second. It is a trig roll.
Which one?
The one that's a squared plus b squared plus c squared. The Pythagorean theorem.
You should get on Rocket
Number
League.
13?
Hmm?
You should get on Rocket.
Yeah, number 13.
That'd be.
In class? You want me to just give y'all work and then you play Rocket League on the projector?
I think that would be really
Yeah,
fun.
it's weird.
That would be fun for me.
It would help my
You do
No,
it
I
by
play for a few
squared,
months and then I don't play
plus-
for a few months. I get bored.
Got it.
You switch one squared plus secant squared.
Yeah.
So you
play
secant
this
squared,
2 months, you don't play
and
Rocket
secant squared is.
It changes. Right now I'm playing some game, AI Omnium or something. I don't know, it's like a story game.
What'd you get for 14?
I'm so far in it now, I'm just gonna finish it. And I started playing Zelda Tears of the Kingdom
No, that's wrong.
a couple months ago, so I need to go back and finish that one.
Actually,
So that'll be next.
science plus 5 that's over natural. Mr. Cow says, how do you undo the product?
Well, what I would do is just do algebra first. If you distribute this y squared, this would just be like y
you don't gotta
cubed
do the
plus
power.
3y squared, and then they're separate terms, so you can just do them separately.
So like the 5 to the x doesn't would just disappear.
Oh, okay.
You should ask Mr. Cow.
Ask me what?
Wait, it doesn't know how to do 14.
I think it's.
You can't all be perfect.
You can though.
No, I can't.
Yeah, you can. You're perfect.
What's it? Wait. That equals secant squared. So what turns into secant squared? Does that make sense? Yeah. That was funny. Okay, so I don't know why I need to do this. Or I didn't know to do it. Brain told me to do it. But Kurt, did you know to do that trigger in Did you just recognize it or what?
I did recognize it, yes.
Basically, you divide, you know that this, that.
If you
I just
see,
said this equals that, so I just replaced this with secant squared.
if you see any trig function that's squared, then it'll most likely.
It's probably a
be-
trig identity.
Unless it's secant squared. Secant squared just transfers to the tangent. More often than not, if you see
Is that what it's called?
trig function squared, it'll be.
You got another 7 yet?
Yeah.
Okay, I got 6.
That's not the thing where you do it, though, is it?
It looks like
So it's not
just
just
constants in front of sine makes it go sine. Why is that?
Just don't get worried about it.
You never worry about the constants in front of trig functions.
I don't believe you do it unless they're being multiplied by each other. Then you have to use undoing chain rules.
Or plus, well, yeah, no, I think, yeah,
Oh no.
well,
It's gonna take you a while.
The second one?
Yes. So this is
Why? The first one would just be 2x squared.
you have to take the the integral twice.
What's 9 times 2 is 18?
Oh, it's actually 19.
I'm sorry, I didn't realize this, but on this first handout, you don't have to do all questions 15 through 20. I'd like if you would at least try one of them to make sure that you remember how to do it. And it is something you're supposed to remember from AB, but I didn't really want it to be your focus today, so. Sorry, I didn't know that they snuck that in there. I was glancing mostly at the first page.
Based on that's what happens when you overachieve. Overachieve.
What's 18 minus 33?
Maybe.
I'm sure you will.
You don't know that, like, you still here.
Understand that?
My struggle is with this. The more on each other.
So which ones are
Do we have to do chain rule?
You said 1 from 15 to 20, and then like you know any of them, and then you do all these.
And how would that affect
It's all mad.
For number 14? Apparently I'm wrong.
Yeah, you did. Or secant? Or maybe I'm wrong and I'm just.
Sine x plus control of C.
Anything at least
what's the
1 over
answer?
natural log.
Sine x plus 5
And then you still need that.
Oh, wait. You gotta use your thing. So what's the inverse of C?
Oh, it's just one of the rules you have to memorize. It was like one of those random rules way back in the day that we looked at for not even a semester, but the integral of sine x.
So all it is
sine
3x
And then when it's 5 to the x, it was
That's it.
that over the natural log of the number.
For some reason I was thinking it was C just surrender function.
Yeah, it was one of those random rules. So that's why.
Which one do you want, Brett?
For number 14, I didn't know. I didn't remember.
What's the tough one?
What?
What's the tough one?
Yeah. You don't know.
Sin x plus. Plus 5, yeah. Number 22. The answer is sin x plus 5x. No. What is it?
Sine x plus 5 x.
That's right. Or that
Number 23.
over natural.
That was this from. It's just a change. So u equals cosine of theta plus x. Du is sine of theta.
I'll do it.
No, actually,
Okay. Is there one that we could pick out from this front page, 1 through 14? One of these that you didn't know how to do right away, or there was some trick you didn't remember, or any? Number 14? Okay. Just for a change of pace here, did anybody get the answer to 14? Want to come up here and explain it for everybody?
I think Braden.
yeah, I think Brayden does.
I don't have to. It's,
Well, I can.
I'm not going to. Okay. Always count on Tommy.
Using Braden's work.
Okay.
Can I draw with this?
Yep, that's what I'm going to do. Pick your color. And
It's too much
then
pressure.
you're good.
Okay, so this one's the beginning of it's easy. Basically, it's just gonna be sine of x that turns to cosine of x.
And then this is where it gets tricky. If you don't remember this from last year, then it's not going to be right. But basically, 5 to the x, the integral of that would be 5 to the x over natural log of x, I think. And then obviously the plus c.
Okay, y'all agree with that?
No.
No. Okay, what part of it do you not agree with?
Oh, sorry. Let's get the eraser. Natural log of 5 is the correct answer.
You can just use the back of it.
Oh, there we go.
I agree.
Y'all agree with that now?
What is
Okay.
that, Mr. Johnson?
Yes.
You show us a proof for it?
What, this part? Are you talking about this part?
Yes.
Okay, well, let's talk about derivative first. The one derivative that should help you remember this is the derivative of e to the x is what?
E to the x.
Okay, well, it's really e to the x times the natural log of e, but natural log of e is... Okay, so now if we're doing the derivative of a base other than e, like a, what would its derivative be?
A to the x times natural log of a.
Right, and oops. And now this matters because this is probably not going to 1, right? So that's why you've got to tack that on there. So if that's how you take the derivative, so when I look at his work here, 1 over the natural log of 5 is just a constant, and then 5 to the x. So here's the constant, and there's the function part. So I'm going to check his work by taking the derivative and going back here. So the derivative of a number times 5 to the x would be, I'm looking at this, 5 to the x times the natural log of 5. I want the 5 to the x. There's no natural log of 5 there, so I need to cancel it out. So dividing by 1, or multiplying by 1 over natural log of 5, or dividing by natural log of 5 is how you do that. So that looks fine to me. That derivative would give me, the derivative of this would give me that. But it sounds like this might be something y'all need to add to the top of your paper. I don't know that this is going to come up a lot on this worksheet, but if you know the derivative to e to the x, and you understand why I'm talking about the natural log of e and natural log of a, then really that's not a new formula, it's just an extension. Okay, was that enough for that question, 14? All right, good job. Okay, is there one more? One more that y'all thought was tougher that I let somebody volunteer to work out? All those seem okay? Has anyone tried the challenge questions at the end? 21, 22?
I'd like to see number 21.
You would like to see it?
Yes. I
Okay.
haven't gotten to it yet, but I'd like to see how.
Oh, well, you need to try it first. I'll give you a minute and then you can come tell us how to do it.
I think we just use some.
Most people just
Oh.
this bottom one would be.
That one's so easy.
Yeah, some of those questions on the back
So it'd be natural
look
log.
easier than some on the front. I don't know why they say those are challenge ones.
Yeah. Brayden, have you done 15?
No, I haven't.
I said
I just
Brayden.
finished up 14. I'm on
So, can you explain how to do it? Yeah.
28's the easiest one.
So we define what f of x is. Integrate x. So we got to integrate 1 over square root of x. Okay.
There's got to be a property to make it
2 x 1 half, right? Yeah. Plus c,
Oh, okay, so there's a property that tan squared theta with tan squared x plus 1 equals secant squared. And that takes away the square root, so it's the square.
So you said that equal to F is 0. You plug in so you plug in 0, so yes, C equals.
I hope so. I mean, after that. I remember.
Then it's just x equals 2x to 1 x squared.
Brendan, you get that 21 figured out?
I'm working on it right now, sir.
Okay, good. We're waiting on you to come work it.
Yes, sir.
Also, now that we're up to double digits in your binder, you've got 10 things for this class in your binder now. If you don't have those in order, it's probably a good idea to go ahead and get them in order before it starts getting worse and worse.
Thank you.
Yeah, folder's fine for a while. Eventually it's gonna be so thick though that you don't want it.
Especially that meter.
So basically,
I used to be no guy, but I think that it's
the
actually
derivative,
paper guy.
so at 0, it's gonna be fine. 1, the slope is 1. At 2,
We're not that hard.
You don't have to do these. You don't have to do the 15. If you finish super early, maybe try one, but again, I'm saying one more time, y'all don't have to do the 15 through 20. If you finish both of the worksheets other than that page, or those questions, super early, I'd like you to go back and try one. But, yeah, so this is gonna be my binder right here.
Wow. Are you serious?
Probably.
What do you put in there?
This is the
How
biggest
many,
binder I've
how
ever
many
seen.
inches?
That's like a
It's
foot.
like 3 inches? 5 inches?
So much. No, that's like 5 inches.
Why do you, what do you need it?
6
Like,
inches.
what do you put in there?
I put my work and try to keep like blank copies, so next year it's easier to make copies
Oh,
from.
that's
And,
smart.
Do you put everything, like, is it gonna be all the way full, or?
well, this would be if I keep all my classes together, probably. If I want A, B, and BC together. But usually I do binders for a class,
Where did you find that thing?
and then I just keep my binders full, because I think that someday I'm gonna go back and use them.
Where did you find that thing?
Well, they sell it at Walmart.
Really?
Yeah.
You know?
Maybe you've heard of it.
Sell everything at Walmart.
It's the most
And then it's the eggs or one spots. I can draw a perfect circle. I'm not even joking.
That's not a dry erase.
Wait,
No, really? I actually can.
I was looking to see that.
No, I'll do it when I finish my work.
That's not a dry, that's a dry erase. That's one of those smart ones.
Going back home now.
I'm gonna go into the screen during like class and just walk in. Just walk out.
Walk out.
So are we supposed to do all of 21 through 28?
So I guess cosine. Cosine goes
Try 'em?
to minus.
Yeah, I mean, there might be one in there that's like
Sine just means.
insanely
minus sine
difficult
should
that I
be
might say
cosine.
don't worry about, but.
So
you're integrating that. And 23.
That's the.
23 is probably the
multiplication of like.
It's just like
Yeah, it's just you just cosine of theta of plus 3.
Yeah.
Okay,
So it's minus.
They're dumb.
Man, I stink at slow fields.
Really?
How
Both those are the easiest.
I know, but I just like can't draw the lines.
I can't draw them straight. Yes. Last year, on our mock exam, I think probably like the 7th or 8th most multiple choice question miss was it.
no, that's
Yes, it
crazy.
was.
That's insane.
I don't
No, I believe it.
understand.
I'm just
William's mock
surprised.
exam was pretty bad.
I don't remember that.
You saw spreading rumors.
I'm not. On his FRQ, he left like the first one and the second one without that much.
Remember this?
I did. Thanks to organic chemistry tutor on YouTube. You know what I mean?
Well, I never met him.
Oh.
Oh, I think
Really safe, remember?
You have to do all of them.
I've got zero.
Oh, I thought you said
I'm doing
I said you don't need, these are a totally different question type. It's fine if we're not reviewing this thing. But just the basics of antiderivatives and maybe substitution. I want you to get practice on it.
Oh, wait, I know how to do this. I'm so sad.
Those sections.
No, I don't know.
HS hours for those are those.
Oh, wait, is this completing the square? Can it?
Which one? What number are you on?
Wondering if that's. It says 2.5. You have to have.
27.
Look at the quarter there.
Isn't that what you said?
No.
27 is not you said?
Not all of them, so you have to have 5.
27 has to be.
It's not
things
you.
that we sent out, but I think
Okay, you do it.
What? You reached your word count. That's crazy.
15?
That's why I just.
I'm like 99 point. I don't know if that's
It means that this would have to be 2x for it to be just simply sub. It's not 2x. The derivative of x squared. Natural log of x squared.
My Saturdays were pretty booked right now with college.
I mean, you can't just have u sub, there's nothing to u sub.
Good.
There's no 2x in
I
there.
don't know the
So
answer.
you have to do.
Probably some
I don't know the answer.
Probably some
Number 23.
What?
How many?
Your Brady said it by me over there. You can't take over.
rule we haven't seen in like.
What about these kids? What about these fools over
Could be
here?
completing a
Yeah,
square.
They're a few
Wait,
questions
is it
past
x
him.
squared plus 1?
And when I'm looking at this,
Oh, yeah, it could be.
Nobody's copying about Brandon.
They're not. I mean, I'm helping them with like the ones that they don't know. They're doing most of it by themselves.
Yeah.
It's talking about
Basic
a
trivial.
trivial.
Okay, but Miss Cross never taught us.
Exactly,
It's
it's not a
full.
You mean Miss Sarah?
Yeah, Miss Sarah.
Miss Sarah agreed with us.
She never taught us tangent to -1 and secant to -1.
Well, that's because they're really only on like 1 or 2 questions total.
She said, don't even worry about it.
Yeah, now I have to worry about
It's,
it.
well, it would have helped you with 1 or 2 questions, but I would argue that if you had more time to study for the AP exam, it was probably better spent studying something else than to learn.
That's why I can't do 27.
Huh?
I can't do
It's just
27.
tangent to the negative. That's why I don't do x plus c.
That attitude you can't do.
I mean, there's a couple AB topics that we don't teach you in AB because they don't get tested enough. Squeeze theorem
Yeah.
and derivative of inverse functions. But we'll have time to do them this year.
Okay.
But technically, squeeze theorem and derivatives of inverses are AB topics, but they're tested so little that we don't even bother teaching in AB. Your time just, unless you've aced everything else, it's not worth your time, is the
I know
problem.
she like showed us them. She's like, yeah, these are what these are, but just don't worry about it.
That's about what I did. I told them to put it on the top of their page on assignments they needed it for so they could reference it. And then I gave them one quiz to make them memorize it like the week before the AP exam. But that's all I ever made them do. So you'll need to know them for BC though. We'll use them more. So
Are we?
not right now. You don't have to stress about it right now. But there'll be a time where we have to be able to do those. So
Are we gonna do all the challenge problems?
26.
yes.
Okay.
U is.
Again, I think some of the challenge questions are easier than some of the questions on the front.
I think you would be.
27. I already know the answer to 27. I just looked at it.
Square, yeah, square.
28's the same thing except times a half. I just did 2 questions.
Would be
U equals
Sorry, what was that one?
x. U equals.
I did 25 also.
just looking at this.
Yeah, that's easy. What's e to the t plus 1? Oh, never mind.
Sine.
I thought it was e to the t plus 1 over e to the t plus 1. I was like, well, that's just 1, so it integrates the t.
You gotta do the power rule and the 1/2 becomes a 2. So it'd be 2 sines.
Well, 1/2. 26.
It's square root of x.
No, it's. Yeah, square root of x.
Yeah, and that's
Well, I was wondering why that numerator was so spaced out and then the denominator was crammed together, but
oh yeah, that's 1/2. So it'd be 2 cosine square root of x.
Yeah. No.
Or I mean sine, 2 sine square root of x.
Yeah, it was something this year I didn't teach us.
I didn't do it.
You just have to memorize it.
Oh.
Did you do 25 right?
Yeah.
You scared me a little bit.
It's
scared.
literally just you final review.
Just gonna write down those.
Yeah, that's pretty much what I did.
So you like
Yeah, the skeleton done. The stuff you come out.
Yeah.
why is it on your desk?
Plus.
Yeah, but you're doing the absolute value.
Well, I was gonna put it there.
If you don't put the absolute value, you get it wrong.
Yeah, well, I was gonna put it there when I wrote it right.
I'm sure you were.
Give me work, please.
What's this
Yeah.
one?
Kind of stuff.
And did the integration in your head and pick the u and the v.
equals cosine of.
Okay, well, the AP is going to expect you to show your work.
I should have known that. That makes
There's
sense.
no way that you'll grade in.
Don't worry.
Where's the table?
What did I not get?
23.
But where is the table?
We got that for 20.
I'm not. I know how to do it. I need to see that you were doing it and not just copying the answer.
I
I
started.
believe you're doing some of that in your head, but you gotta make a habit out of showing your work. That's part of math. It's gonna be that way in every single assignment all year. If it's something that's number 27, if you have that one memorized, you're done. I don't expect you to show a bunch of work there. But if there's steps to be done, you need to write them down. You're sacrificing a lot of your grade to not write down things that you're doing in your head anyway.
The biggest cheat code for slow fields are just trying to get them clear. What sheets do like class?
Oh.
So fast.
I like the later
Oh, yeah.
Like,
Not pretty good.
M
It's like,
equals.
my line's kind of the same, but I say like, this is.
No, it's fine.
I can see that this is steeper than this is steeper than this. It's a little bit of a jump. I'd say this looks like it's probably 1.
yeah.
That might be 2 or 3. That's a little bit steeper.
Yeah.
That's how they do it. So
If you really want to worry about it, you just write M equals.
Yeah, that's what I meant.
the other thing is when these show up where you have to make the graph like this on the AP exam, it's usually just like 6 or 9 points they have you do. So
Okay.
it's not as
Okay, anybody need me to come over and help with something? Slope fields or antiderivatives?
Mr. Council, will both these pages see next class, or is only page nine?
We'll see. It's looking like both, based on how people are doing.
What time is it right now?
It is 9:35.
What class goes out at 10:20?
Yeah.
Okay.
Yeah, so y'all still got, what, 45 minutes or so? 45 minutes, yeah. So you still got half the class.
Advisory's longer than any class we have. We're
Really?
like,
How long is advisory?
like, we have more advisory every week than any class.
Okay, but advisory is 5 hours every week, and on, depending on which day of the Friday is, you have 3.5 hours.
So you
4.5
just prove
hours.
So you
Yeah.
just prove
So you
it.
prove
So
my
I
point.
just proved it.
Yeah, but yeah, but how often do you go to your advisory class for advisory?
Fairly often. Probably not as the year
Twice
goes
a
on.
week?
Most is twice a week.
Obviously Monday, but probably Tuesday.
Tuesday next week.
I think advisory should be very optional.
If you need to go somewhere and learn
Something is great, but if you don't, an hour.
Then what do you do?
On campus.
And you sit around on your phone, you can't do that anymore.
We'll play with Carnap. Go with Carnap.
We can start a math club.
Carnap's it.
The ride will move off
You
the
said a
thing.
little louder.
I've never slept in my car.
What's on my lunch? That was 2 years ago.
That's what
Exercise would be
We should start a
Sigma,
math club that I love you.
whatever Greek.
There was this student-led club that somebody was trying to bring back. I think it was Claire Brandon. She was trying to bring back some, like, the biggest student-led club that participated when COVID-19 hit. It was like, it wasn't on at the National Honor Society levels, but it was like,
And then
it was a pretty big club. I think it was like 150 students one year.
What club was it?
Charity
Some
club?
volunteer service work.
Nice.
Not the good one.
macro micro club.
Oh.
No, there already is like a finance club or something.
Investments.
There's a young investors club
Holy
that.
moly, Brayden, I'm so good.
What was y'all thinking of a
No, I
rugby
mean
club?
yeah.
What?
A rugby club.
A rug? No.
No, you wouldn't do that?
Rugby club?
I would not.
They should
Yeah.
put like a pickleball club and we can get like those little
Yes.
pickleball.
That's like, no,
there is.
pickleball's like an old people thing.
Yeah. We should play tennis club.
It's for geriatrics. No,
pickleball's so fun.
What are you talking about?
Pickleball is fun, so.
We could do like band club or something.
No,
Just give
no.
random people
No.
random stuff.
You can't have a
Oh,
club
like
that already
percussion, like
exists in the
triangle. You wouldn't want to hit a triangle or a drum.
I like triangles.
I like the
Somebody
bass.
likes fun.
Yeah.
The bass drum.
Yeah, somebody likes drums. You wouldn't like to just hit random instruments.
I want them to do a rage room.
That would be a fun club.
Yes, you do a rage room club.
Yes.
That'd be so expensive.
Oh my
That'd be
god.
Well, you could just buy like you could go to Goodwill and buy like a whole bunch of used
That's what they
glasses.
do. Have you seen how much they charge?
That's really long.
Okay, but like that would probably be so good for students' mental health though.
No, that stuff's not good for your mental health. Push your energy out mentally.
What if we had like a
Like for me, for
escape room club?
that would actually be good. You put them in Mr. Townsend's room, man.
You put him in Mr. Townsend's room and have to solve all their riddles.
I mean, what happens if they don't get out?
They're stuck with town.
LZ in here.
I wouldn't say that if that sounds weird.
You don't need to prove everything. People are in a certain criteria. Using.
I can't draw a straight line.
Yeah, that's how I can do.
You draw a curved line.
That's why school fields are the
That's the only
hardest.
type of line I can draw.
I've learned so much art appreciation. It's actually amazing.
Art appreciation.
Yes, I've actually gotten better. We're not really appreciating, we're actually drawing. But
Ben, do you feel lonely over there?
Okay. Fine. Alright. I didn't need appreciation.
what's it written?
Ben, where have you been sitting for lunch?
That's great.
You will.
It is.
Yeah. Interesting. Food rescue, is that who you're in? Or no?
technically I could sit with you on 8-is, but I don't have a 4th, or I mean a 6th or 7th. So I usually just go. I mean, I could always hang out with it one day, 1 or 2 days. Okay, because I was like, oh, Ben's not here, right? I'll wait a little longer. Maybe never showed up to the cafeteria.
No, there's something.
Sine of 0 is 1,
No, it's 0. Cosine of 0 is 1. Unit circle.
Come on, Brayden, you don't know your unit circle?
I do.
You know that for calculus.
Okay, you still got about 40 minutes. Please let me know what you need help with.
Mr. Townsend, am I correct? You only have to do one problem on 15%?
I would like you to try one of the questions from 15 through 20, but only after you do all the rest of it.
Okay.
And the other worksheet.
Sine of 1.
Questions 15 through 20, I did not mean for y'all to review today. I didn't realize those were different on the back. But I would like you to try one if you have time.
Where's 1 on the unit circle?
We'll review that topic another day.
Is it 5 on 5? No, it's not great. Well, sin of pi would be that, but sin of 1 is not.
Well, I mean, if you just think of a sine graph, but
I don't know what sin is.
that's all in, that's not, this is in terms of 1, 2, and 3. I know.
Not pi's.
It's really like a sine
That's
graph.
not.
That's. I'm pretty sure I'm correct, so. This would be positive, all of these would be positive. No, you do it. That's bless you.
Thank you.
Good for you, I guess.
That's good for me.
Okay. If you guys would, make me feel better here. Pick at least one question we can go over. One of them that you thought was tougher.
25.
Question 25. Okay, so either jump to 25 now or might need to watch this video here later. Okay, so the mistake I made on 25 a few minutes ago was I glanced at this too quick and I thought this was a 1 and this is actually a T, so that's going to change how that works a little bit. So my thought process is I hope that this just looks like the opposite of a derivative I memorized. That's not the case. I hope that I'm just undoing power rule, which is not the case. The next hardest thing would be U substitution, so that's what I'm going to try here, and I don't know if that's going to work or not, but I'll give it a shot. And then if that didn't work, I'd have to start considering partial fractions, and I'd have to start considering integration by parts. It's not going to be either of those two, but that's where my brain would go. Okay, so when we take this derivative with respect to t, because t is the variable here, we get e to the t plus 1. So du is e to the t plus 1 dt. You okay with all that? Okay, so now when I rewrite this question, what is it going to look like in terms of u's? Okay, 1 over u, and right, all of this is equal exactly to du, so that's a perfect substitution. Sometimes you have to do one more step. If there's chain rule involved, you have to do one more step there. Okay, how do we integrate 1 over u?
Natural log. Have you?
Close. You need the absolute value too. Natural log, absolute value of that. And
Plus C.
plus c. And again, if you're willing to take the extra 10 seconds out, just take the derivative. You would get 1 over this times the derivative of the inside because of chain rule. And you would get what we started with. So that's how you can be sure your answer is correct. If you take the derivative of your antiderivative, it should go back to what you started with. Okay, Blake, was that enough for that, since that was your question? Okay, is anybody else, anybody else going to ask about 25, need to, while it's still up there? Okay. I'll leave it up on the screen.
Mr. Collins, help with 26.
Uh-huh.
Could you do 20?
Sure.
Could you do 20?
Let's look up.
Yeah.
All right, 23. So again, this definitely doesn't look like something I have memorized. It doesn't look like it's just undoing the power rule. So then the next hardest for me would probably be u substitution. So that's what I'm going to try next. Although it does kind of look like integration by parts. You're integrating something times something. But I'm pretty sure u substitution will be fine. So I'm picking this out to be u. Hey guys, can y'all wait a minute, please? I can't talk over you. I'm picking this out to be u because it's stuck under the fifth power here. So du d theta, because theta is the variable here. I'm taking the derivative of this side, take the derivative of this side, which would look like this. Multiply your d theta over to separate your variables. And I don't know why I forgot this plus 3, but all of these were theta plus 3. Okay, and then hope that you're ready to start making some substitutions here. So I know in place of all of this mess that I highlighted, that's equivalent to u to the fifth. That's what I'm calling u, and it's to the fifth power. And then the other step that we have to replace is sine of theta plus 3 d theta. Right now, I don't know what sine of theta plus 3 d theta is. I knew what negative of that stuff was. But multiply this by negative, multiply the other side by negative to keep your equation balanced. So I need to do a negative du to substitute for that stuff. This is the chain rule step. And again, as much of a pain or as much as you may not like u substitution, U substitution process is, it's this step right here, taking what you have versus what you want, that is doing the undoing the chain rule for you, and you're not having to juggle that in your head. Okay, so now I'm just going to raise the power by 1. I'll plug this back in for you and divide by the new power. Since this is an indefinite integral, we need to add a plus c since we didn't have limits. Okay, did you find your mistake in there?
Yeah.
Okay.
Thank you.
Sure.
Yeah.
So just find
Did you do number 27?
You want to do 27?
Yeah.
No, on the back.
Isn't it just inverse tangent of x plus c?
Yeah, probably.
Okay, then you need to add this to the top of your paper.
I
So
don't remember it.
the derivative,
So, one answer on this page.
so we memorize all 6 trig derivatives. There's also 6 inverse trig derivatives. But there's really only 2 of them that show up a lot on the AP exam, inverse sine and inverse tangent. So you need to be familiar with these, because a question like number 27 is just an automatic if you know that.
Nice.
But also, it's kind of good for you to see that it's not undoing power rule. It doesn't look like anything else we've memorized. You can try U substitution if you want to. It's not going to help you. The only way to do that is to recognize that pattern.
You said inverse tangent and inverse what are all there?
And inverse sine. Inverse sine.
Those are the only ones we need to know, really, probably.
I need to double check for the BC exam, but for the AP exam, this is the only one that they ask, or these 2. Inverse sine and inverse tangent. But honestly, inverse cotangent is the same as inverse tangent, but it's negative. It starts with the c, so it's negative. The derivative of inverse cosine is really the same as the derivative of inverse sine, except it's negative. So, really, if you memorize these 2, and you know how they match up, you kind of know 2 others also.
Nice.
But the derivative of inverse secant and cosecant is pretty messy, and I don't know that one off the top of my head. It's like 1 over absolute value of u times square root of 1 minus u squared or something, I don't know. I've never seen them ask those on the AP exam. So.
What identities are we also able to know if we have these ones memorized to say?
Inverse cotangent. Remember how we talked about last time with the trig identities, or the trig derivatives? If it starts with the c, it's always going to be negative.
Yeah.
So these 2 are actually the exact same thing. It's just that inverse cotangent would be negative instead of positive. And then inverse cosine is exactly the same as inverse sine, except he's negative. But I've never seen these show up on the AP exam. I will double check for BC obviously at some point this year. I'll make sure that y'all know what you need to know.
How are you just like see what you want and then just do y equals 4 cosine and multiply by -2. Yeah, you're solving for c, so you just c is 1.
Bird? Yeah. You show me your subfield for number 1.
You just plug in.
Were you not just...
I know how to do it, Blake did it wrong.
Whoa, hey.
See?
You were talking about how easy it was, and you didn't believe me.
You eating lunch?
Yeah.
At 10.
Social wasn't
And then y equals times 2, or c equals 2.
Yep.
No, the same with the,
Yeah.
it changes the
I
actual.
don't think so.
So
There's no differential between this and
Wait.
these, bro.
These aren't the
would
easy
change.
ones. These aren't the hard ones.
I heard
Well, this one would be what? 1
1
over y minus 1
Yeah, it's gonna change it.
dy over 1 dx minus what?
I didn't know.
Log absolute value.
Yeah, you're right. You're right. It's 1 over a negative 3, so it's negative 2, right?
It's obviously just if you can name your parts. I mean like just gonna get each individual thing and this your substitution for all the parts. And what's that? The box or something.
That seems to be logical right here. For some reason, it's very correct. Which is your
And then you plug in 1. Negative 1.
What's your workload?
This gives me the wrong answers. It is. Which I think I simplified it more. I didn't do it. So I don't know. So it would be cosine equals 3 squared over
So it would be if you go for 11.
Y equals negative 2 dx plus 1. Plus 1.
E to the 1, because it's e to the x, so you have the square.
Yeah.
Okay, let's see. Would be negative 1 plus k e plus 1. This one's correct coordinates would be negative 2 over e. So y equals negative 2 plus e dx.
Right, this is what I thought. Oh, it's 3.
Times 0.
Or that actually makes sense.
Oh, and you, I didn't know how to estimate ways off.
So you have,
I'm trying to reconcile.
Well,
Okay, that makes sense. Mr. Townsend?
Yep.
In your, on the website, that's
Mhm.
a negative, it's a negative 2 times all that.
Okay.
Do you know if that's?
Well, so if I take the derivative of your work here,
Mhm.
this would do power rule. So you would bring this down, those would cancel, and that's why that's a 1.
Mhm.
You'd lower this power by 1, which is why that becomes a negative 1/2. But because the derivative of this inside isn't 1, the derivative of the inside is negative 1. So that's where the chain rules come in and involved. This isn't negative, and this is going to make it negative. So you need to slap on a negative there to cancel it out.
Okay. Thank you.
Also, you could do U substitution, because U substitution is what does that for you.
Gotcha.
So,
Is the one that looks like amplitude. It's up, down, down, up.
Mr. Townsend, can you do U substitution for anything?
not anything. There was like this number 27. You either recognize that derivative or you don't. U substitution wouldn't help you.
One is
Um,
by over 2, so it would be increasing for F1, it would be decreasing at 2.
But there's lots of times you could use it,
increasing,
but it would be very silly too.
and that you can't make exact.
Like, I don't know. I guess you could try to do number 7 with U substitution. I don't even know if that'll work, because then you don't have the DU. So I guess that wouldn't work there, or the DT.
Last 2 close to
Yeah, I was thinking you could maybe use U substitution on some of these questions, but I don't think you can.
You don't know, or is there something that you can look at and it tells you you can use substitution?
Well, all I'm doing is, in my head, I'm trying to imagine what would I even pick out for you such that then when I take the derivative, it's going to be the other parts, and that doesn't seem like that's going to fit to me. So that's how I have a hint that it's probably not U substitution. But also, when it's this, like, U substitution, it's a process and it's nice to know, but it's also kind of time consuming. Stuff like this, we should just have memorized. And stuff like this, we just have memorized. So, I mean, even if U substitution worked, I think you'd be crazy to do it because it's so much more time consuming. Yeah.
We did, that was the one, I've messed it up first, because the evaluations, I have like an 80 in class, really, because I like the tests and things.
Are you serious?
Because there's only like a few labs.
Okay, I had a question for number 24 real quick. So, this doesn't look like anything I have memorized. It does not look like undoing power rule. It's pretty close to that, but not quite that. So my next option would be U substitution. If I try to pick this to be U, because it's stuck under the exponent of 100, du dt would be 3. Also on this, how do I know it's du over dt and not du over dx? Right, t is a variable in this question. Also, this is a dt. So, okay, so then I start trying to make replacements here. It looks like in place of all of this, it's the same thing as u to the 100th. But this is why I really think you're doing yourself a disservice if you don't keep up with this dt. I know it seems like it's unnecessary because a lot of times you can get the answer right, but you need to have a visual of, I've substituted this stuff, this is u to the 100th, but I haven't substituted for this. And I don't know how big dt is. I know how big 3 dt is. So divide this by 3, divide this by 3. dt is the same thing as 1/3 du. And again, this 1/3 is the undoing of the chain rule. As much of a pain as U substitution process is, it's taken the mental gymnastics out of it. Okay, to finish the question, now to integrate, I just need to undo power rule. So raise the power by 1, divide by the new power, throw on a plus c, and instead of saying u, you should plug u back in.
Was this working for you?
And on a test, you'd probably want to check your answer by taking its derivative. Is that okay? Yep. Did y'all do much U substitution last year? You don't remember? I make my classes do like 3 days of it. They're sick of it. But
We got so good at it.
well, I wouldn't go that far, but
We got okay at it.
aren't you glad that you did all that practice though?
I am, yeah. On the slipkins, did you just draw the line, or did you actually draw the slipkins on front?
the actual.
You just drew the line, you don't actually draw the. On the solution to that, I don't know why.
Does he assign random lab groups? Or does he let you choose?
How's the mathematics at the end of the table without anything negative?
So one of them is pretty smart.
No,
One of them, one of the five.
Say what?
That's like sits next to that short that short one is so long.
So I'm gonna go for a few days and then I'm going for the kids back next week. They're supposed to have
Most of them are long. Logan?
Yeah, it's not Logan over like twice.
Yeah, he didn't tell.
Next time I'm working hard.
Let's see moments. X.
It's white triangle, so it's probably X.
Whenever you plug in X, it's well, the sine one's easy. The sine one's just B.
Yeah.
Oh, really, David?
I don't know what E to the negative things would look like.
It would be instead of exponential growth, exponential decay. So that one would be.
Oh, so you.
Mr. Townsend,
Yes.
could you explain number 3 on the slope fields?
Okay. This number 3?
Yep.
Okay, so slope fields give us an equation that's the derivative, so it's telling me the slope at all these times. So I don't know, try plugging in 0 for x. What's the sine of 0?
I is definitely C.
0.
Okay, so anytime x is 0,
I is definitely
the slope will be 0.
Okay.
Um,
Because it's just shifting 1 over.
I could do pi.
It's just,
Mm-hmm.
The sine of pi is what?
which is
Sine of pi is 0.
that's y squared.
That's true. So over here, this looks like this about 3.14 right there, so those are all 0.
And everything in between would be positive. That makes sense.
So that would be.
Okay. What about negative pi?
Negative pi, 0.
Because y squared, like when y is
Okay.
0. This.
I don't know. What's some other values of sine we know? Sine of,
2.
okay, pi over 2 is a good one. What's the sine of pi over 2?
1.
Okay. Where's pi over 2 on this x-axis?
It's like 2.07-ish.
That sounds way too big. How big is pi?
3.14.
I think you're right.
So pi over 2 would be 1.5 something. 1.57.
Okay, so at about 1.57, you see why the slopes have to be 1?
Okay. So we don't have to graph on the 1, 2, and 3.
Well, what you could do, because it does look like they're implying they want you to graph those. This is just the sine of 1. The problem with that is we don't memorize that. That's not to say that we can't ask our calculator what's the sine at 1 radian. It's about 0.84. So anytime x is 1, the slope is not quite 1. It's a little bit less than that. See what I'm saying?
Yeah.
So you need a calculator to estimate those values. But
Okay. Cool, thanks.
Why did we did that at first? Well, then the last one was
Minus y is without.
What's the sign after powerful? Square root 2 over 2.
Well, I kind of figured that since it's the last one.
It's probably,
Yeah.
Yeah, one is.
can't be, because it's decreasing here. One would have to be, wait, yeah. Getting confused. This one, oh wait, no, yeah. Yeah, okay.
You just gotta plot it and then draw with the stuff.
For zero to
that's not
zero,
that.
do I just?
Yeah, just put the dot and just follow the dots.
Plot the following.
You just figure out where it's going to increase the market. You see and know where it's off as well.
Do we do the whole slope fields worksheet or just 1 through 6?
Well, 1 through 6 are probably the most tedious parts.
Okay.
You don't need to do 7 through 12, but I'd like you to do the other page.
Okay.
You just plug it in for each dot, you just run a line with the dot.
Okay, guys, we've got about 7 minutes, so let me do a couple quick reminders here about where you need to be and what you're on the hook for and what you're not on the hook for. So you might need to mark up your worksheets here just to be clear. So on our first one today, which was assignment number 9, this antiderivatives and indefinite integrals, I would like you to do at least try all of those questions, but you don't have to do 15 through 20. It's great if you remember how to do them and you want to do them. I will give you more time to do those and we'll review that in a later date. But the other questions, 1 through 14 on the first page and 21 through 28 on the back page. Any of those that you struggle with and or your answer does not match up with the correct answer on the website, circle those and make sure you have those ready to ask about. I can't promise we'll do that on Monday, but we'll do that at some point. The other worksheet, assignment 10, slope fields, same idea. I'd like you to do the front page and the back page, but you are not on the hook for questions 7 through 12 right now. I will ask you to do 7 through 12 at some point, but I will give you a reteach on that before I expect you to do those. I was really just wanting you to do some antiderivatives and some slope fields today. Okay, and then finally, I do have a new puzzle for you guys, although this one is, you're not going to get the answer in 5 minutes, but you're welcome to start it and maybe brainstorm some ideas how you would go about doing it. It's actually pretty interesting once you start working with it and coming up with the answer. It's not as hard as it seems like it would be. It's very doable.
It's just like a different advisory,
And as I've been doing, I will post a YouTube video that shares the answers and the explanation. So if you're interested, it's stuck.
No, this would be
Or you finished and you want to check your answer. There's also more than one way to do this puzzle, by the way.
That is really hard.
Don't you have to find out how many lots each has one?
Now, once you get going on it, it's actually not that bad.
What's
Each husband has spent 63 more than his wife.
It's a computer science problem.
So that means each husband has spent 63 more dollars than each wife.
no $2 each?
Yeah.
Segment.
each husband has bought 63 more hogs
Oh.
than his wife.
It's
No.
just 2 costs 2 each.
If you buy 63 hogs, they cost $63 a piece.
Oh my goodness.
If you buy 20 hogs, they cost $20 a piece.
That's not how supply and demand works.
How would you know?
Oh,
How would you know?
I'm in macro micro.
You're in week 3 of macro micro.
I know every single dollar is guessing every single.
If you like logic puzzles, this one's a pretty cool one to stick with. Obviously, if you give up right away and just see how to do it, it's not as rewarding, but it is a pretty good one if you figure it out.
If we get in the next 2 minutes, ask.
You should ask. I'm not asking.
Hey, pull park out. Don't worry.
Do you have baby life?
8:30? 8:30. What?
We as in you.
The band.
Is that supposed to be like a chicken bone?